we will measure the performance of high-end model, namely the GS7 amplifier. We remove the top cover and place a temporary cover instead. The amplifier is connected to the mains with a PowerCon 32 ampere connector. Now we turn the amplifier on. During the power on time, the amplifier performs self-testing and the level LEDs light up for a while. Besides, the fans start to run at full speed for a short time too. During this process, the amplifier cleans up its heat sinks and checks the operability of the fans. Let's check the activation threshold of the amplifier. Gradually increasing the voltage, we can see that the amplifier switches on at the voltage of 150 volts. Let's check the threshold of the overvoltage protection. Gradually increasing the voltage, we see that the power turns off at the voltage of 270 volts. Gradually reducing the supply voltage, we see that the tune-on threshold, which is 260 volts. Now let's try to connect the amplifier to a 400 volt mains. We turn on. Visually nothing happens. The amplifier protects itself against such voltage. Now we will apply the test input signal to the amplifier and connect a 2-ohm load. It should be noted that during the testing of such powerful amplifiers, driving a low resistance load, you have to be careful with the mains power supply. Pay attention to the mains current consumption. Now let's reduce the level of the signal and check the total harmonic. At the higher signal level, the distortion factor slightly increases. The shape of the output signal distortion indicates the predominance of crossover distortion. Let's check how the distortion changes upon the switched load resistance between 4 ohms and 8 ohms. Let's measure the output power of the amplifier. At the mains current consumption fairly high, we will use the pulse signal for measurements. A music signal peak factor rarely exceeds the value 1 to 3. Let's apply to the amplifier input a test signal consisting of 1 kHz sine wave burst, 100 milliseconds long, separated by 200 milliseconds pause. It is hard signaled for the amplifier because the capacitors run off in 100 milliseconds. So our measurements are equivalent to the measurements of the sinusoidal signal. Let us use this special calculator. It correlates the output power with the output signal swing peak to peak. The amplifier supply voltage is 2 per 190 volt. We will measure the signal swing with a digital oscilloscope. At first, we see a large output signal amplitude. This is the peak output power of the amplifier. Then, after the discharge of the power capacitors, the output power becomes steady. Let's unfold and view the steady amplitude area in more detail. Then we will enter measured amplitude into the calculator. Now let's estimate the peak output power. In our case, it is the power that the amplifier can yield within the first 10 milliseconds after applying a high-level sound signal. Finally, we will measure the noise level at the amplifier output. To do so, we disable the input signal and look at the instrument reading. The noise level is 0.9 mV.